about anything. Okay, let's do this. Let's finish the other side of this thing. I want to show you a very important process that we've actually been building up to. All right, let's take a look at this. Let's do this one first. What is this the graph of? Does anyone know by any chance? Absolute value. Kick-ass. Because it says, no, you're not allowed to go negative, so this makes a hard turn, right? None of us want to be in that plane. We're going to take a world. So you don't want to turn that quickly. But it forces it to stay positive. What's interesting about doing that one first is you could actually calculate exactly what the slope is. How many slopes does that thing have? How many values of slope? 2. Yes? On this side it's negative, on this side it's... Can anyone tell me exactly what it is here? Yeah, what is it? Down 1, over 1. Down 1, over 1. Yes? So, let me really get you guys... You cannot always do this. Why can you do this here? Because it's a straight frickin' line. So of course I can calculate the slope easy as shit. Just rise over run. You guys with me? You won't always be able to do this, but I do kind of like to start with one that you can do it to. Because now, for example, what'd you just tell me? Everywhere on this side of 0, what's the slope? -1. So at this point, the slope is -1. So I'm going to plot the value of the slope. Yes? So if my function is going down, my slope better be down here. Do you get that? If my function's going down, my slope must be negative. So therefore, the value of the slope must be down here. Does that make sense? So on this side, the value of the slope is, so that it better be freaking up here, yes? So what is the slope at this point? -1. Okay. So all the way across, it's -1 until you get to 0. After 0, what's the slope forever? +1. Now, a really good question would be, what the shit is the slope at 0? No, it's undefined. Then you can't say it. There's no slope at 0. It's undefined. Okay. That's why I put 2 open circles there. That's where it's turning. And it's even worse than a parabola, because a parabola has a 0 slope here. This thing has an undefined slope, and in fact, you see what that slope does? Isn't it a jump discontinuity? At that point, so that point is free. We call it a non-differentiable point. Can't do it. So any kink in the graph of a function will have a non-differentiable. It's undefined. The slope is undefined. Yes. Neat. Here. Does anybody else need this one? Remember we did this one last time?
So if the thing said f of 0, it would be undefined or it does not exist?
Oh. You ready? If I ask you what f of 0 is, what is f of 0? 0. If I ask you what the slope at 0 is,
Then it's
undefined.
Okay.
Yeah. The function value is perfect there. In fact, is it continuous
Yes.
through 0? Is it continuous through 0?
Yes.
Why? Because it looks like it's approaching 0 from both sides, and it actually gets to 0. What's continuity all about? Not only does it have to agree on what it looks like it's approaching, but it also has to actually get there. Looks like we're going to 0, so it better get there. There's a hole there. No, it's not going to. You guys with me? Yes?
You have to be able to take the first derivative.
Yes. So that would be not differentiable at 0. It can't take the derivative of 0. That's why the derivative of 0 is undefined. Now, look at the first problem. This one is much harder to do the way we did this. But can you guys at least tell me this? Here is the place you want to start. And trust me, I gotta get you to understand. Let me see how I can say this correctly. This is really simple, but you have to have it click in your head. It's one of those kind of things. Really, that incline I drew on top of the absolute value. I drew, everywhere I drew through represented the slope at that point, yes? So you have to keep telling your brain, hey brain, I'm graphing the slope right now, or else you just sort of like start graphing the line, the curve I did. Can anyone tell me on that first curve, roughly where the slope is 0? Because what's the slope here? Tell me anything about the slope here. Positive, right? And here it's even bigger positive, yes? So it's really big positive, but it's getting smaller and smaller and smaller until it gets to, yes, because after that it's negative. So any turning point that's not a kink, that's going to be where the slope is 0.
It's closest to 0 when you're at like a graph's minimum or maximum then?
Yeah, a graph's minimum and maximum, as long as they're not some kink, you know, like it goes smooth, the slope is 0 there.
Anywhere where it starts to round out then?
Yes, that's another way to look at it. Any turning point that goes through smooth, it doesn't go like, you know, like the absolute value did, that's a 0. Why does it only make sense? Positive, negative. So what must it be in the middle? 0. That's the only way to go from positive to negative, right? Or the other way. So, what value does the slope have roughly right there? It's not perfectly a -3, right? What value did we just say?
0.
So I'm about to plot something that represents the value of the slope at every point. So it only makes sense to give myself some anchor points. Let me find out where this thing is 0 and plot those. So it's 0 here. Flattens out right there. So it's 0 about right there. Where else? Where it bottoms out, yes? Which is roughly a little before 3. Okay. So the dots I just graphed are values of the slope at those points. Now, just to make sure I don't suddenly die, let me see. That'll be traumatic. Sorry. Remind me what you said about the slope over here. Yeah, in fact, down here the slope is like, it's positive, but it's really big positive, yes? It's almost going straight up and down here, yes? So if I'm going to graph the representation of what the value of the slope is here, it's going to be big positive, yes? And as I move here, what's my slope, value of the slope doing? Getting smaller and smaller until it hits 0. I really want you guys with me. This is big positive slope, correct? And what you're about to draw is the value of the slope. I don't know exactly what it is. I could guesstimate the slope here, like it's up 1, 2, 3, 4, 5, 6, 7 over 1. So I guesstimate the slope here is about 7. Well, that's perfect. You don't have to do that. You just have to know it's big positive. But we're going to put it at 7, yes? As I move, the second I move a little bit, my slope gets smaller and smaller and smaller. But it's still always going up, yes? If this is a graph of my company's profit, I am happier and happier and happier, yes? Until we get there. And then we're like, no, wait, no, what? Stop. Okay. So it goes just here, it's a little bit smaller positive. Here, it's smaller positive. So it's basically doing, God dang it, Jeff, should be a little curvy. Because our graph is curvy. Now, what happens as I get past this point? The slope becomes negative. And then I have to, again, the slope becomes more and more and more negative until you get somewhere in here. You guys with me? Somewhere in here, what happens? The slope starts to get less and less and less negative, yes? It's still negative, just not as negative. So somewhere in here, the slope is the most negative in that area that it will be. So that's kind of neat. So somewhere in here, about right here. It's always negative, and it's getting more negative until about right here. In fact, I could do an estimate again. Screw the estimate, let's just keep going. I really want you guys to, so the slope is negative. Gets the most negative it's going to be, and then it's less and less and less negative until it's 0. So watch how you check yourself. Slope here is negative, correct? Where did I put the point on the graph I'm making right now? Down here. Oh, that makes sense. If my graph is going down, what I'm graphing better be in the negative part. Now what happens after this point? So I'm just going to keep going. Yes?
How did you know where to go? Where to cut off when you were coming down?
Oh, how to turn? How to turn? Okay. That's not like crazy important, but I want to really, later we're going to figure out exactly what this point is. It's very, but you guys see how it's more and more negative? Yes? More and more negative. And then somewhere in here, it starts to go the other way. It gets less and less negative. So more and more negative slope. The slope here is -1, the slope here is -2, and then in here it gets the most negative because then it starts to turn back. So now it's still negative slope, it's just not as negative. Even less negative until it's 0.
Okay, so it's just going to be one of those things of conceptualizing that for now.
And it's a weird ass thing. So many guys are like, yes. Could you close that door back there, man? Oops. I'm like old man in the house. Keep my AC. All right. Now, what am I going to do from here? The slope now gets positive and it keeps getting more and more positive, yes? And this is where students focus too much, is I am going to end up kind of following the graph now. But the only reason I'm doing that is because that's what the slope is doing.
It is basically 7 to 1.
Now, let me ask you this. How many turning points did the original graph have? 2. Do you guys, and in fact, that graph, what is that the graph of? Does anyone know? Is it x squared? The original graph? It was x to the 3rd, yes? It was a 3rd power. The line we just drew looks roughly parabolic, it looks like squared. Interesting. Interesting. All right, maybe I'll do another example here in a bit. We'll see. You don't have to worry about what I just said. It's going to come into play when we get to section 3.1. 3.1 is going to be your favorite, I think. When we start to, I'm not even being facetious, it's when we start making shortcuts to some what we do. Okay. Oh, talking about differentiable. Can you guys see where where's the graph just have issues? Just automatically, where's the graph, where does it have continuity issues? At 3. So if there's any continuity issues, that's automatically not differentiable. So it's not differentiable at 3 because the function is discontinuous there. But there are 2 other places where this is not differentiable. Yes, -2 and 1. For the same reason, yes? So this is not differentiable at x equals 3 because it's not continuous. And it's not differentiable at -2 and 1 because it's got a kink. So we're not shaming it, we're just pointing out that there is an instantaneous change, and that's a non-differentiable thing. If I graphed, in fact, let's do this. Let me push my luck here. What's the slope here? Yes, fine. In fact, it's 1, 2, 3 over 2, so it's about 3/2. Yes, so it's about 3/2 until this point here, yes? What's the slope now? What's true about the slope here? Negative. And it's getting, what's really weird is it's getting less negative. So it's here, it's getting less negative until here. What's the slope here? 0. And then what happens to the slope here? Positive, yes? Until it gets to here. What happens to the slope here? 0. And then the slope becomes positive 1. I just wanted to tack on there, just graphing the slope. That was a lot of linear pieces, so that's really nice. You can just calculate the slope directly. That was more than the question asked for, yes?
Once you get to -4, restart it again.
Do it again, sorry.
Restart it at -4.
Oh, here?
Yeah.
Here. This here?
At the y-axis, -4, sorry.
Oh, here. Oh, here. That's where this is going down, but it's being less and less and less negative, yes? So it's negative, and then it's less and less and less negative.
It's because the
Like
slope
wherever?
goes from a positive value to a negative.
No, I got that, the y,
Oh, yeah, I
the
just
y
put it.
value is -4.
Yeah, I'm with you. I could again estimate down 1, 2, 3 over 1, so it's about -3, so I really should have put it there. But when it's curvy, I'm not gonna make you do that. When it's a straight line, you can get the exact slope. When it's curvy, we just kind of estimate about where it is. Okay. And I have used this word before, is that true? Yes? Okay.
Yes.
It gets a little weird when I'm like tutoring and I'm doing it and I'm like, did I even say that? Okay. What does that word, I'm sorry, what does that word derivative mean? No. It doesn't mean. What does derivative mean? Slope, exactly. Derivative is the calculus word for slope. So this number 2, it gives me the slope, the derivative here. So what is the slope of g? What is the slope of g between -5 and -2? No, careful. This is g prime. This is the derivative. Did I give you a graph of g? Did I give you a graph of g? I gave you a graph of g prime. I did not give you a graph of g, yes? You guys with me? So whatever this says is the slope of g. So what is the slope of g between -5 and -2? 3. Could you draw a representative line from -5 to -2? All you need is any line that has a slope of 3. Do you understand? I want you to, let me see you guys for a moment. If I just tell you the derivative is 3, what's the only thing you know that has to be true about your line? It's got a slope of 3. Do you know where it is? If that's a slope of 3, is that a slope of 3? Is that a slope of 3? Is that a slope of 3? Is that a slope of, yeah. So I didn't tell you where it is, so you can draw it wherever the shit you want to, because all we know is the slope. This becomes very important pretty soon for us. If I just tell you the slope, you don't know where to start. So this problem, that's why I say sketch A possible. Because there's literally an infinite number of answers you guys could give me. Slope is 3. Do you guys agree that's relatively kind of big? It's not 3 billion, but 3 actually is pretty big for the small scale. Are you guys understanding what I'm saying? So I don't want to start here and go up 3, I'm already off the graph. I'm going to start with the shit down here. What is the only thing I know about G, given this information? Yeah, between -5 and -2, it's got a slope of 3. That's the only thing I know. So what is one possible function between -5 and -2? If I start here, I can go up 3 over 1, up 3 over 1, up 3 over 1. So G could have looked like that. If we had this problem on number 1, and we try to graph the slope, wouldn't we have just graphed 3? Because the slope of this dumb thing, so we're just doing that backwards now. What if somebody knew the slope? Can you just graph what it could have looked like? Yeah. So could you start here? Yeah. Could you start there? Yeah. Could you start there? I guess. If you want to go way off graph. Could you start between? Yeah, I don't give a shit. All you need is a line that has a slope of 3. So, what's true between these two? This one's going to be a little silly.
0.
Slope is 0. Yeah? So therefore, what's G gotta look like?
Straight line, right?
So that you can actually, this could be your answer. You understand? Or anything between -2 and 1 that has a slope of 0. Are you with me? So if I want to make it a little more clear, I could pick anywhere. I could even do this if I look at what I can do, everybody. Ooh, yeah. Okay. Does that segment have a slope of 0? If you give me, you could say, no, it looks negative, John. All right, give me a break. Are you guys kind of with me? So we have to understand, if they give me F, what information can I get from it? If they give me F prime, what kind of information can I get from it? I can get slope information from like G prime, F prime. So keep going. What's true about the line between these 2 points? These 2 inputs.
The -2.
Yeah, slope's gotta be -2. So if you wanted to, I kind of like, with these problems, I kind of see if I can like connect them. You don't have to, you can make it go anywhere, but if you start here, I would go down to over 1, down to over 1, that's where it's -2. Are you guys understanding? You could start wherever the shit you want to. In fact, let me do that just to kind of break things up. I could start here if I wanted to. A little jump discontinuity. Down 2 over 1, down 2 over 1. Oh wait, Jeff. There you go, buddy. What are you doing to yourself? Okay. You could have put this segment there, up here. I don't care. You put it anywhere. Slope -2, you're good. What's the slope between these 2? 1. So then I can start here if I want to, and go up 1 over 1. Yes?
Bear with me really quickly, Professor. I'm probably just missing something, but the continuation from 1, 4, 1, 3, why is that down a unit?
Do it again, sorry.
At 1, 3, I know it's open circle. Is it just because since we know it's open circle, it's not a continuation?
Yeah, I could have made this a closed circle, to be honest. It doesn't matter, because I know it's not differentiable there, but I could have made it a closed circle.
Okay, I just wanted to know why we were a unit below. I figured that was why, but I wanted to be sure.
Because I could have started anywhere I wanted to.
Okay, now again, just arbitrary, just important to realize
all agree with me
that
that
it's discontinuous, so they couldn't be in the same.
If I ask you to graph a line that's got a slope of 2, now to be really honest, most of you guys would make a line through the origin. But could somebody make a line not through the origin and still be right? Yeah, of course. If all I know is the slope, there's an infinite number of answers. Okay. This one gets a little freakier, yes? Because what's happening to slope from here to there? Slope starts off. All right, let's see if you guys are ready. What's the value? Again, this is a graph of G prime, and G prime means slope, yes? So what's the slope at this point?
1.
No, what's the slope at this point? 1. The slope is 1. This is where the value of this, that's the slope. Yes? So the slope is 1, so I'm going up. And what's happening to the slope? Getting smaller. So what's the slope right there? So my graph I'm about to make better do what there? Curve, and right there it should turn. So I could start off, and I can start wherever the shit I want to again. So I'm gonna give myself a little room. Start here, and it's +1, so I'm gonna go in this direction, but then I'm gonna get less and less and less until right here it turns. And now what's true about my slope?
0.
Yeah, right there it's 0, but now what's true about my slope here?
-1.
Now it's negative, so now it's gonna keep turning until I get to there. And I made, yeah, that's almost right. I'll be okay with myself. Okay. So the slope is +0, negative. Okay. Probably would have been better if I went there, but it's okay, I'll be alright. What's true about the slope between these two? This one's nice. Slope is -1. So if you want to keep your function together, just start going down 1 over 1, down 1 over 1, down 1 over 1 until you're done with that like -1 section. Now what is my slope here? Still -1, but now what's it doing? Yeah, right here, my slope, so it's negative, but it's less and less and less negative until it's 0 here. And then what happens after that? It turns, yes? So then I could use only that. Not, okay. All we're doing is drawing a little line, giving a slope. If I would have just said that, you would have been like, well, yeah, that's easy. This is difficult though, because you're looking at a graph, making a new graph, and you have to keep reminding your brain, what do I know? What does that mean? What do I know? What does it mean? Okay, so let's do this. The really funny thing is, you're all gonna appreciate that we're about to go into something more computational, less graphical. Everybody done with that? I'm sorry. Okay. Do you guys remember this from way long ago? We did stuff with this recently. What did this represent? Bless you. Bless you. Almost. It leads you in the direction of getting the tangent line. But what is this itself? Yeah, it's a bunch of secant lines, but in the limit, you get the slope of the tangent line. Yes? So that's the slope of the function f at any point. We did an example where if I wanted the slope of the function f at 1, I would plug a 1 in here, yes? That's section 2.7. We did examples like that last time. If I just plug an x in, it actually gives me the function that tells me the slope everywhere. That is very useful. If I have a straight line, the slope could be 2. And we don't think of that as a function, do we? Because it's just frickin' 2. But if I have a curve, the slope is doing what at every point? Changing. Right? So if I say, what is the slope of a parabola? You can't just give me a number. You actually have to give me a function, correct? If I want to know the slope of 2, I better have something to plug a 2 into, and it'll spit out the derivative. It'll spit out the slope. Are you guys at all with me? Straight line, number, done, because it never changes, boring, blah. Curvy shit, I'm like, oh crap, if you want to know it here, it's different from over here, and it's different from over here, so I need a function that will tell me its output would tell me what the slope is everywhere, and of course that's f prime. So this gives me f prime. So let's try an example. Now again, just to remind you guys, this was the very first thing we did. We talked about this, y2 minus y1 over x2 minus x1, yes? We talked about algebra needs 2 points, and so if we can only make it get closer, I can make it look like it's 1 point. And then we said, oh shit, we need to invent limits. So then we went on this whole, tangent of talking about limits, and we had to invent them, we had to see what they could be used for, and now we're finally coming back, oh, we got limits, let's go back to this shit. Can I figure out the slope everywhere now? Yeah. What do I need to be able to figure this out? I need f of x. Do I have it? Yes. What else do I need? H is just h. So do we have it?
X.
What else do I need that I don't know yet? F of x plus h. Can you guys just do that for me? What's f of x plus h do? Oh wait. And just tell real quick. What is f of 3? What's f of 3? -3. How'd you do that?
Just plug it in.
Good. What is f of Jeff? Jeff squared minus 4 times Jeff, yes? Sorry. Which equals, who knows? So what is f of x plus h?
X plus H.
x plus h squared minus 4 times x plus h. I mean, function notation is one of the most single-minded, stupid little things. It's like, whatever you put in me, put it in. So if I replace x with x plus h here, I replace x with x plus h there. Whatever the shit's in there, you just put it in there. It's crazy. People make this whole big deal out of it. Who gives a shit? Now, can I do anything to simplify this? Hell yeah. I'm gonna make a mistake. I'm gonna make a mistake. I am making a mistake right now. I made a mistake right now. I'm gonna make another mistake. I made another mistake right now. 2 mistakes. Don't write that down. If you wrote that down, scratch through it. Scratch through it. Scratch through it. I know somebody's gonna be like, this is what you said? No. So what mistakes did I make?
You can't separate.
I've got a foil. This is bullshit, yes. And what's the other mistake? Didn't take the negative with me here, yes? That's bullshit. Okay, good. You make that kind of mistake, it screws the rest of the problem over, yes? Because then it doesn't work the way it's supposed to, and I'll show you why. We already know what we want to have happen. Can you guys remind me? Let me see if you guys remember. What do you get if you try to plug a 0 in? What do you get? What do you get on the bottom? That's already a big problem, right? But then it gets worse, because what's the top if you plug a 0 in for h? Fx minus f of x is 0. So 0 over 0, which is indeterminate. So what are we trying to do? What do we hope happens in this limit process? We hope the issue dies. Again, not a life lesson. Learned over the last few days, but we'll get. So I am hoping that once I plug this stuff in, stuff cancels, and especially I want the h to cancel. If the h cancels, I can put a 0 in. I killed the problem, right? Okay. So if you don't do this correctly, everything's bad. So how do I do this officially? What is this?
X squared plus 2xh.
Good.
H squared.
Kick ass, and of course distribute the -4. Okay. That is f of x plus h. Oops, except I forgot something, of course. Did I? No, I got it. Okay, good. So now we can piece together the limit definition. So this is called, I haven't said this yet, the limit definition of, can I spell? No, derivative. That's the limit definition of derivative. I will promise you this, after this first test, we will come back to this in lecture. I will not make you do this again until possibly the final. We will start developing shortcuts. Can you imagine if this would have been a 7th power? Do you see what I mean? You guys start to see what I mean. If this would have been a 7th power, what would I have had to do here? Write x plus h 7 times, and then go slowly in sync. As I foil and foil and foil and foil. So, dear God, we got to make a shortcut, yes? Okay, we're not there yet, too bad. So now can I piece this together? I put f of x plus h. Become an h. Minus, and here's another big mistake people make, minus f of x. So I'm going to subtract the entire f of x all over h. And you see a lot of shit start to cancel there, right? What cancels? X squares cancel. X squared minus x squared. Negative 4x minus negative 4x, yes? Notice everybody that's left has what in it? Everything that's left has an h in it, yes? This looks like I killed it, but I didn't. Is everybody with me right now? You guys with me? This isn't very advanced mathematics in the middle here, but the limit and all this other stuff. So now what happens in each term, I could just, every term can just lose an h, right? So 2xh divided by h is 2x, h squared divided by h is h, negative 4h divided by h is negative 4. And now what do I get when I let h go to 0? X minus 1. That is the function that represents the slope of this function at any point. So 2xh divided by x, h is 2x, h squared divided by h is h, negative 4h divided by h is negative 4. Yes?
I noticed you had parentheses at the end there, x squared minus 4x.
Totally. So I
Yeah.
have to subtract f of x, and f of x is this.
Oh, right.
Yeah.
How'd you get the 2x minus 4? Where'd the h go?
Limit as h goes to 0. So plug a 0 in for h, and that's what I get. Could we plug an h to 0 in the first place? In the beginning, could we plug 0 in for h? No. Why can't I do it now? Because we killed the factors of h that was making it indeterminate, yes? Okay, so if you've done enough of your homework, you've seen that happen a lot when you're doing these limits. Conjugate, factor, get fractions together, eventually stuff cancels. You're like, oh, I can plug this shit in, yay. Now, of course, what's the very first thing you try if I just give you a limit question? Just try to plug the damn thing in there, because maybe it just works and you don't have to do any work. Don't start factoring and conjugate and all this shit. Just try to plug the number in. Okay. So let me show you. We started with this. We started with that function, and we just discovered that the slope at every point is this. What's this guy's job? This guy's job, if I plug a number in, it tells me what the value of the function is. What is this guy's job? If I plug a number in, it tells me what the slope is at that point. Yes? Later this semester, we'll talk about what about the second derivative? Isn't this a function? Couldn't I take this guy's derivative? Can you guys do that without much work? What is the derivative of this? 2. Kick ass, because I just asked you what the slope was. mx plus b, it's frickin' 2. Do you guys see that? Do you guys really? Again, when I say derivative, we know that's the calculus word for slope. So sometimes in this class, you're gonna have to step back out of the math and go, derivative slope, you just asked me the stupid slope, it's frickin' 2, I don't have to do shit. What's the slope of this thing? I gotta do some shit. I don't know what the slope of that, there it is, there. Why does it make sense it depends on x? Because it's curving. It's not always the same. It depends on where you are. So could you find the tangent line to this function for x equal to 2? So what's the slope? And what's the point? We don't know, Jeff. You don't seem to ever have a point. Be quiet. If I want to get the equation of the tangent line, I need the slope and I need a point. Yes? Sorry? Yes. That'll be 4 minus 8, negative 4. Yes? Do you guys know what that equation would be then? Slope is 0. It goes to the point 2, negative 4. You shouldn't have to do a lot of work. If the slope is 0, does the y value ever change? It stays at the same level, right? So what does that mean? What's y at 2? So what is y always? So what's the equation of the line? Yeah, sweet. If the slope is 0, the y doesn't change. If I know the y value one place, I know it everywhere. Okay. So that, do you remember the problems in algebra that said, find the equation of the line that goes through 1, 7 and 3, negative 1. Do you remember those round problems? Yes? We had to, you first got m is y2 minus y1 over x2 minus x1, and then you pick the point, you plug it in, y equals mx plus b, or what's the other one? Y equals mx plus b, y minus y1, m times x minus x1, yeah. Okay. Do you guys remember that equation? Y minus y1 equals m times x minus x1. Okay. Alright.
Will we have to memorize all of the formulas for the quiz, or will we have a sheet with formulas, or?
For the test? What formulas are we talking about?
I don't know, like for instance, the point slope.
Oh, you should know that. Hell yeah. So you should know this. You should know this. You have to memorize this. I would say those are the main ones. Okay. Let's do, here, let me do one more example. See if I can push my luck a little bit. Oh, wait, there is something I forgot. That's true. I'm glad I'm thinking about this. In the book, this comes up, and I think I forgot to talk about it. If you're doing the homework at some point and ask you kind of problems related to this. As x goes to 0, we can make a table of values. But just to cut to the chase. As x goes to 0, that ratio goes to 1. So what's sine of 0? 0. And x obviously would become 0. So that's indeterminate, correct? So the only way we have to kind of like evaluate this at the moment is through a table of values. And if you get really close to 0, the outputs get really close to 1. So it's basically 1. What that means, let me see if you guys are really cool with this. What that means, does anyone have the calculator out? Make sure you're in radians for this. What this means is if I'm really close to 0, sine x, if I multiply x up, is roughly x. If this ratio becomes close to 1, then this becomes close to that, yes? If I told you I divided two numbers and I almost got 1, I got really close to 1, the two numbers I divided have to be really close to each other, yes? So in the limit that I get really close to 0, that ratio is 1, which means 1 is roughly equal to the other one. If you got your calculator out and you're in radians, can you do sine of 0.001? What do you guys get? By the way, to make sure you're in radians, hit mode.
Is it 0.001?
Yes, sine of 0.001. Oh yeah, get this. This is a great time to talk about this. What does that mean?
Really small.
Be very specific.
4 places to the left.
Yes, move it 4 places. This is scientific notation, right? Times 10 to the next. So you just move it once and then 3 more times. So 3 zeros. So 0.000999999. Yes? If you round that up, what does that become? Which is roughly equal to what I plugged in, yes?
Mm-hmm.
So when the angles get really close to 0, sine of the angle is roughly the angle. We use that trick in physics all the time. If I have a pendulum that barely swings away from its equilibrium position, I can replace sine theta with theta. And it makes a lot of the computations easier because we're talking about very small oscillations. Do you have to know everything I just said? No. But it's a really cool place we use this kind of idea. Okay. Yeah, I think I'll save the other bit for later. It's fine. Because I want to focus, I want to give you enough time to really talk about review. I've got the answer key for the practice test. Does anybody else need a practice test? Okay. This is our first review day. Some of you guys have had me before, so. Oh, you? Okay. You know how this runs. You can ask me any day. You can ask me a problem from homework. You can ask me several problems from homework. You can ask me a problem from the quiz. You can ask me a problem from the practice test. You can ask me a problem from your head. You could say, Jeff, I still don't understand what the hell limits are. You understand? This is the time to do it. You can ask whatever the hell. If nobody's asking anything, the floor is yours. If you have no questions, then we could all just sit around staring at each other. Hopefully somebody asks a question. Or maybe I'll ask myself a question. We'll see. Did anyone have time to try the practice test out? Do you have to do the practice test? Hell no.
Did we go over squeeze there?
Oh, good.
Because it's on the practice.
It's also in the homework. Semi-quickly, the squeeze theorem is kind of cool, but it's not, you don't see it a lot. So, this is squeeze theorem. Good Lord, Jeff. I'm writing as well as I'm talking.
Go on another class, just read your writing.
Yeah. If you wanted a teacher you could read the writing, you've chosen poorly. He chose poorly. Has anyone run into this in the homework? Squeeze theorem. Yes, okay, a few guys. So you could try to see what the chapter kind of explains about it. Here's why it's called the squeeze theorem. If I had a function that lived between two functions forever. So what does this really mean? This means that g of x, let me just draw a little bit of it. G of x does this thing, h of x does this thing, and f of x is in the middle, yes? H is like a ceiling, g is like a floor, is that cool? And f is in the middle, living its life, yes? But it's constrained. So here's the idea of the squeeze theorem. What if at point A, the limit as x goes to A of g of x equals L. And that is equal to the limit as x goes to A of h of x. So g of x goes to L and h of x goes to L. It all goes to L. Does that say anything about what f has to do? Do we know anything about the limit as x goes to A of f? Have you guys ever seen The Terminator, the first movie in the 80s?
Yeah.
Remember at the end, what happens? Right, Terminator's crawling through that thing. If you've never seen The Terminator, you're fine, but you guys have all heard of hydraulic presses? So this is like the h function, this is the g function, and the f function is the Terminator crawling through. And it's so the Terminator, at first, you can kind of go up and down a little bit, you know, it's got a little room, but then these are squeezing in. And in the limit, if they both have the same limit, they both touch, what's the Terminator got to do? He's got to agree with them. There's nowhere for him to be. He's got to be the same thing. So here's what's happening. If, let's put L here, just to be nifty. If at A, the limit of H is L, the limit of G is L, what must F do if it has to stay between these two? The limit of F has to be L. I like it. I keep putting L in the wrong place. It's okay. That's why we call it the squeeze theorem. F lives between H and G. If H and G become the same value as each other, F has to be that because it's got to be between the two. It's only got that one option now. So what the shit does that mean in terms of solving a problem, Terminator boy? Here. So if I had to figure out what the limit as x goes to, I don't know, let's see, 2 of do you all agree weird things happen at 2? Yes? Very weird things happen at 2. If you really think about it, exceptionally weird things happen at 2. What does 3 over x minus 2 do as x approaches 2? 3 divided by x minus 2. If I let x go to 2, and let me be even a little more careful. The bottom is getting closer to 0, so the whole thing is getting closer to 3 divided by really small is really big. What does cosine do forever? Oscillates between -1 and 1. If you let that go to infinity, is it approaching a number? It's no, come on. Is the limit 1? No, because if you go a little further, it's like 1 away from 1, correct? Is the limit -1? No. Is the limit 0? No. Because it does this forever. Are you with me? I need you to be with me. So what's a limit mean? Eventually I have to get closer and closer and closer to a number. That's a limit. Does this ever get closer and closer and closer to a number?
No.
However far it is away from 0 on average, it is eternally that far away from 0 on average, yes? So there is no limit. Not because it goes to infinity, but because it oscillates. So the math creative geniuses, we call that an oscillatory non-convergence of a limit. So the limit does not go, the limit does not exist because of oscillations.
Wouldn't have a loop, but it's still, the y are still the same on it, so why
So it
wouldn't
has
the
a-
limit be?
So again,
Zero, so that would be.
you ready? Again,
Limit the max.
if the limit were 0, that would mean eventually, what was I doing, cosine? Eventually, it would have to get closer and closer to 0. Does it do that?
Mm-hmm.
How far away from 0 is it right here?
Yeah, so
1. How far away from 0 is it here?
Negative.
And here it hits 0, doesn't it? But does it ever start to get arbitrarily close to 0? If somebody said, I want you to be forever this close, can I ever do that? No. But what happens when you pluck a guitar string? Thank the gods. If you leave it alone over time, it will stop oscillating. Just imagine if it didn't happen. Every guitar string ever plucked would still be going.
So that's like.
So if I pluck a guitar string, I take it out of its equilibrium position and then it starts to oscillate. So it would look like this. But it's dampening over time. What's this limit? 0, because it's getting closer and closer and closer. So the whole idea of a limit is I have to eventually get closer. How close do you want me to be? I can find a place where I'm always that close. So if I have something that is eternally getting far away, the same distance away from anything, there's no limit. There's nothing it's getting closer to. It doesn't have any agreement on where it's going to be. So if I had a function that had a horizontal axis that does this, isn't that eternally getting closer? But if I just do this, am I getting closer to that line? Am I getting closer to it? Am I getting closer to it? No, I am not. Okay, maybe. Is that all right?
yeah.
For a limit to exist, and since we're talking about it, at infinity, I have to say I can get as close and stay that close forever. As close as somebody asked me, can you get this close and stay that close forever? If I can, like up here, if somebody said, I want you to be forever this close to 0, I'm like, oh, if I just go this far, I am forever that closer than that to 0. I can't do that shit with regular cosine. Okay. Sorry. Everybody is looking at me, but you're all looking at me like this. Does that make any sense? For a limit to exist at infinity, I must eventually get as close as somebody wants me to get to it and stay that close. If I don't, that can't be the limit. It doesn't go there. Okay. So, this guy. Weird shit's happening, yes? But I really want you to see, I don't care what I put into a cosine. I do not care what I put into it. What can come out of it? What are the only things that can come out of it? Can any number come out of cosine? I don't care what I put in. I really want you to understand. I don't give a shit what I put into it. What's the most and the least that can come out? Negative 1 to 1. Y'all with me? I don't give a shit what you put in. You can put the weirdest shit in the universe. Cosine can only be at most 1 and at least negative 1. Yes? So, here's how squeeze theorem works. It says, find the thing that is bounded. Because what's it all built on? A function being caught between two things. Wouldn't you all say that cosine is caught between 1 and negative 1?
Yeah.
Okay, so you find the part that does that, and then you just say exactly what we just said. This is eternally stuck between 1 and negative 1. Now students sometimes balk at this, like, well, what did you do with the rest of the function? I'm like, I don't give a shit about the rest of the function. I'm writing a true statement about a part of it. How do I make the middle become the function I have to look at? How do I make this guy become this? What do I have to do? What's he missing? What's this missing that this guy has? X minus 2 squared, right? How do I give it to them? I multiply everything by it, yes? So I'm gonna multiply this by x minus 2 squared. This by x minus, and this by x minus 2 squared. This feels weird, but we plucked out the part that lives between two things, so I can make it look like, I forgot how I set it up, g of x less than f of x less than h of x, yes? So I've got this stuck. Now I bring in the element I had to leave off. I bring the x minus 2 squared in. In the middle, do I have the function that I need to say something about? Yes. Now, what's the last thing I'm missing that the question wants me to figure out? The limit, yeah? So let's take the limit of all of these. The limit as x goes to 2, the limit x goes to 2, the limit x goes to 2. Do y'all agree with me that the middle is the stupid thing we don't know in the first place? Yes? The middle is just the thing I don't know from the beginning, yes? So I don't know how to do that. That's the whole problem. Well, what's the limit of this? As x goes to 2? 0. What's the limit of this as x goes to 2? 0. If this has to be greater than or equal to 0 and less than or equal to 0, the only option for it is 0. We squeezed it. We trapped it between two things. They both become 0. They both become the same value at the limit. This guy can only, so now I know this limit is 0. Because we squeezed it. So how do you do a squeeze theorem? If they didn't set the inequality up for you already, you take a part of it that's stuck. Normally it's going to be sine cosine because those are things that are stuck. Do you guys remember we talked about arctangent before? Is arctangent stuck? Between negative pi over 2 pi over t. Yes? So they could have an arctangent. They would give you a piece that you know is bounded. It's got a ceiling and a floor. Then you multiply by whatever else you're missing. You take a limit. You can squeeze it. Done. Yes? Next one. Okay. I don't want to spend more time on it because the squeeze theorem is neat. It comes up like once or twice maybe, but it's not the main thing. It's not the main thing.
So the same concept will apply to sine.
Yes, totally, because sine is also bounded. Now, if I put tangent there, would that work? Tangent goes to, it's not bounded. It goes into infinity and negative infinity, outputs. Arctangent, it's bounded. Okay. So if you wanted to, you could try out on the practice test. There's that squeeze theorem question. Or if you have a different question, we can move to that. Yes.
Could you work through C on the practice test?
Oh, yeah. Oh, yeah, this one's neat. So remind me, what's the first thing you do? You question your prescription on your glass. There.
Plug in.
Plug it in? What do you get when you plug it in?
You get negative 2 over 0.
But, here's a kicker. Let me see if you guys are really with me. You get negative 2 over 0, which is not indeterminate, but what does that mean? If I get something that's not indeterminate, but the bottom is 0, the answer is going to be some kind of... Yes, it's going to be some kind of infinity, yes. You guys with me? The only time I must definitely do work is if I get 0 over 0 or infinity over infinity. Then I have to try to factor it. But here's the kicker. Yeah, go ahead.
Oh, no, I was saying, like, we're not, isn't it asking as it approaches 0 from the right?
Yes,
So we
totally.
plug in, like, the other numbers to see what it approaches?
You don't have to make any table. I don't want a table, in fact. If I don't ask for a table, don't make a table, because then you'll lose points. I need you to really get this. Everybody agree the top would become negative 2?
Yes.
Everybody agree the bottom goes to 0?
Yes.
Can anyone tell me if the bottom would be negative or positive as it does that? I can't tell. There's too much shit going on. Y'all agree with me? So let's try, so the only reason I'm about to do what I'm about to do is because there's too much stuff. gonna try to factor this. How do you factor the bottom?
Take out an H.
Okay, take out an H. Yes? That did nothing for me, yes? But we had to do it. I don't want to, that made it sound like, good, thanks so much. But we had to do it. Can you factor this now? Now, let me see if you guys are cool with it. All right, listen. Normally students, especially the factoring that is required here, you're like, oh, come on with this shit. Because you have to do 12 to the negative 6, and you have to blah, blah, blah. What is the only thing that could happen that would make it useful to factor? Can somebody tell me, what's the only thing that could happen that would make this useful? If I find exactly what? If I break this up and I get, part of it is 3h minus 2, yes? Do you all agree with me? Anything else, there's not a damn reason to do it. You with me? That is why I can do what I'm about to do. I'm going to assume that part of the answer is freaking 3h minus 2. I don't know if you guys have ever seen this. I could be wrong. And if I'm wrong, I go back and I try to do this a different way. But I'm going to assume part of the answer is 3h minus 2. What would the rest of the answer have to be then? Well, that's a 3h. What do I have to put there to get 12h squared? 4h. If that's a negative 2, what do I put there to get negative 6 at the end? 3. And then how do I check, did I get the right middle term? Negative 8h plus 9h is negative 8h plus 9h is h. Hey, so then that's true. If I didn't get the right middle term, I would cross all this shit out and try something else. These go away now. So let's see what we got now. Now I can tell what's going on much better. The top is 1. So it all depends on the sign of the bottom. What kind of numbers am I plugging in for h? Numbers that are positive, yes? If I'm plugging in positive numbers, this is positive, and this is positive, and that's positive, and I know it's going to some kind of infinity, and now I know it's going to positive infinity. Chaboom. So that's an example. I really want to make sure you understand. The only time I have to do work, we did factoring here to get rid of some of the extra shit. There was just too much shit. The only time I have to do factoring or conjugate or something is if I have an indeterminate form. And I really hope you guys hear me when I say this. That word, math people, we suck. We suck at naming things. Have you guys noticed this? We suck. Sometimes we're really good. We're like, it's good. I know the point and the slope. Let's call it point slope because, you know, it's right there. But we did a great job with freaking indeterminate. If it's indeterminate, I cannot currently determine the answer. So I have to simplify it somehow. If it's not indeterminate, I can currently determine the answer. You guys see what I'm saying? This one had so much shit, I had to get rid of some of the shit just so I can see it better. You with me? But it wasn't indeterminate. Yes? I could have made a table of values and figured it out. I could have, but I don't want you to. I'd rather you simplify it a bit. You guys don't want. So don't immediately start doing conjugate and all this weird shit. Plug it in, see if it's indeterminate. If it isn't, you should be able to determine the answer. Okay, maybe. I'm not going to give you one like this, I don't think. I kind of pushed my luck with this one. We'll see.
Can I ask you a question?
Yes.
I remember that, like sometimes they will like just focus on the highest exponent, just so like that you see.
Oh, totally. Yeah, totally.
Like, you know, kind of like the bottom is growing, you know, kind of like at a faster rate than the top,
Yes.
and then like that you can figure that it's a positive infinity.
Totally. That's when I'm going to what? That's when my variable is going to what? So remember when you could just focus on the degrees? You guys remember, like if the degrees are the same, it's the ratio of the coefficients, that kind of thing. What's it require that my variable be going to? The limit is my variable goes to infinity. That's when you could do that. Yeah. That's related to horizontal asymptotes. And also in pre-calc, it's the three like ways to find a horizontal. Similar, same degree, ratio coefficients. Degree at the bottom bigger, 0. Degree at the top bigger, slant asymptote.
So we have a problem that says, find the following ungraded, that's going from
Oh.
one side, like in 3C. When you get close to the answer, you're kind of assuming, like, because then, so like in parts 3B, you find you would actually find the limit exactly at
Yeah.
that, at that
Yes.
point.
Yes.
But in 3C, you
All right, let me make this really quick. Let me give us something that's got a lot less shit. Let me make yeah, this is really okay. When you plug a 2 in, is it indeterminate form?
Yeah.
Let me try this again. When you plug a 2 in, is it indeterminate? No. What form is it when I try to plug a 2 in? I get -3 over 0. Yes? Now listen. Ow. When I see that, I know the answer is some kind of infinity. So I don't have to be precise because it's frickin' infinity. The only thing I have to worry about now, my whole thought process changes. Now I'm like, all right, is it going to be positive or negative? So this one's got a lot going on. Top is negative. I'm letting A go to 2 from below, yes? Okay. Top is negative. So I'm going to put a negative up there. What's the bottom if I let A go to 2 from the left? So I'm putting in what kind of numbers? Numbers that are... No. What does this mean? What side of 2 am I on? The left side. So the numbers I'm plugging in are related to 2 how? Are they bigger or smaller than 2? Smaller. So if I'm doing 2 minus a number smaller than 2, is this positive or negative? Positive. What's negative divided by positive? So it's negative infinity is the answer. Done. I knew it was an infinity because it was finite number, non-zero divided by 0. I know it's an infinity. My entire perspective changes. Is it negative or positive? You guys with me? If it's indeterminate, I have work to do. If it's not, I should be able to determine the answer. And what are the only 2 indeterminate forms we know so far? 0 over 0, infinity over infinity. If it's one of those 2, I have work to do. Maybe, is that all right? So like this one, if you plug a -6 in, what do you get? Zero over 0, yes? And what would that tell me? Am I going to infinity? Am I going to infinity? No. Going to -6, right? So can I do the degree thing? Nope. That only works if I'm going to infinity. So what do I have to do instead? Try to factor this. I try to simplify it, and the form it's in requires me to try to factor. I'm hoping something cancels. Specifically, I'm hoping like an A plus 6 cancels. You guys with me? That would be a factor that's making both of these 0. If I can make that die, I can then plug -6 in and be safe. That's the whole idea behind simplifying limits. I'm trying to kill the thing that's not letting this number go in. If I do that, I can put that number in. What do you have to know how to do? Factor cubes. Do you think I'm going to give you a cube problem on the test?
Yeah.
Hell yeah! So if you don't know how to factor cubes, you might want to kind of get that shit down. Does anyone want some help doing this?
Yes.
The cubes. Can anybody tell me what's the first thing you put down when you do cubes?
Small.
Little dude,
brackets, bigger
big dude.
brackets.
Yes.
And
So
then
let's look at
close
this.
opposites.
Little dude, big dude.
Then you have
What's A cubed made of? A.
A.
What's 216 made of? What do you think? What's a guess?
372.
Huh?
72.
No. You got to think multiplicatively. 72 times 72 times 72 is way too big.
That was 30. That's
6. If you don't know, just start, breaking it down. Do you guys know where your cube root button is?
Yeah. Oh, no.
It's really cool. If you hit the most intriguing button on here is the math button. If you look, there's a cube root. To be really, really honest, do you need to do that? No, because what is a cube root? How can you rewrite a cube root to the what power? 1/3. So if you do 216 to the 1/3 power, you'll get 6. So that means this is 6 times 6 times 6.
But we won't have a calculator on this test.
Yeah, you will.
Oh,
Of course.
Unless you don't want one, do you?
No, I won't.
Oh God,
No, it's not. Yeah, okay.
We've entered
No.
we've
So
entered the
mean.
kind of
she
mathematics.
says no, so I'm not gonna let anybody know. I'll be so
Oh, no,
mean.
'cause the
You
quiz
can
is-
have a calculator.
No, we've entered the point of mathematics where a calculator is necessary.
Sometimes. Not really, but you can have one. So I identify, it's 2 terms. It could only be squares or cubes. It's not just cubes because that's a 3, it's cubes because I can cut everybody in thirds multiplicatively. That's why it's a cubes. What goes in the little dude? He's a little dude. So what can I put in the little dude? 1a, same sign, 1/6. So what goes here?
A.
The other 2 a's. What goes at the end? The other 2 6's, yes? And how do I get the middle term? Yes, you multiply this. And what's the sign have to be? Huh? It's gotta be negative so it can do its job. What's the middle term's job? Middle term's job is to kill the extra shit you don't want. So it's gotta be the opposite side, yes? Did we talk about that? I'm pretty sure we did. No? Did I say about Pulp Fiction?
Oh, yeah.
Yes?
Yes.
Okay. Normally people remember when I say that. Okay. So listen, the factoring is, alright, factoring is crazy fundamental. When does it show up? All the damn time. All the time. It shows up all the time. I can't make this crucial. If you're not good at factoring, that's a really good thing to find time to kind of focus on. Yeah. Do we have stuff in the sisal?
Yeah.
Shit, yeah. We have videos. Yeah, we got all kinds of stuff about factoring because we all know it's crazy important. Okay. How do I factor the bottom? Yeah, I can take a 2a out and look with a squared minus 36, and then this. How do I factor this?
Minus 6.
Yes.
Plus 6.
And then I can cancel,
And a plus 6.
which is the problem, right? That was why I couldn't plug a -6 in. I just killed the problem, which means now I can plug a -6 in. Yes? I really hope you guys see that. That's almost too nice. Can't take your limit at first. Simplify, kill the problem. Now I can put the number in.
I don't know how to factor.
Yes, that's a huge point. Yeah.
I was fine.
Okay, maybe. Now, of course, look at part A. That looks like I want you to factor it, doesn't it? Do you have to factor this one?
No, you just
No,
plug in.
you plug it in, it works. You get a number, you're done. Yeah.
-3.
So if I give you a limit problem, dear God, just try to plug the number in first. See if there's a reason to do more work. Now, I didn't give you an example, like a conjugate, where you have a radical. So if I had rad x plus 2, you would multiply by rad x minus 2, right? And then, like, if you have fractions, you would try to combine them so you can simplify it, yes? Those are the 3 main things that can happen. Factor, combine fractions, or conjugate.
How do we find the domain range for the 3 root 4s?
Yeah, dude.
Down the camera.
Yeah, what about that guy? Fourth root.
Period.
And again, let me ask you again, anytime you want to, we can. Do you guys want to bring complex numbers into our calculus? Alright, so therefore, what must be true about 16 minus x squared to keep this real? Has to be negative? Can't be negative, yeah, so it's gotta be at least 0, good. So 16 minus x squared must be greater than or equal to 0, yes? Alright, so you write that down. Then you work with it. So, I don't know if people don't trust me. If I give you a function, say what's the domain? Say in English what the issue is. The inside has to be at least 0. Write what you just said in Mathish. Solve, done. Inside 16 minus x squared has to be at least 0. How do you solve that?
Oh, same on 16.
Huh?
X has to be greater or equal than -16 square root.
Okay, so if I subtract 16 and then I divide by a negative, I get here, yes? Take a square root, you have to be careful about something. What is the square root of x squared? Nope.
X to 1.
What's the square root of x squared?
X to
Is it x to the
negative
1/2?
The only thing you're missing, could x be negative? Yes, x could be negative, correct? So what's the square root of negative 3 squared? Negative 3 squared is 9. What's the square root of 9? 3. It was negative 3, now it's 3. The answer to a square root must always be positive, or 0. So I have to force my answer to be positive, and what is it that makes every answer positive? Absolute value. Right? So the square root of x squared is the absolute value of x. So the absolute value of x is less than or equal to 4. So could x be 5? Could x be negative 7? Try it. What's the absolute value of negative 7? Is that less than or equal to 4? Do you understand what I'm saying? So maybe we're not used to absolute values in inequalities. I always call this the sandwich. What's absolute value? Why is that always positive? Because it's distance. I want my distance to be less than or equal to 4. So I can go up to 4, isn't that less than or equal to 4 away from the origin? Down to what? What else is within 4 of the origin? 0 is 0 away from the origin. What else is 4 away from the origin? Negative 4, so that's negative 4 to 4. And again, I was trying to get you guys to think about this concretely. Can it be negative 7? No.
Oh, no. 'Cause
Absolute value negative 7 is not less than or equal to 4. Could it be negative 3?
Yeah.
Could it be negative 4? Yes. And that's as far as it can go. So how far down can it go? Negative 4. How far up can it go? 4. So it's between negative 4 and 4. That's the domain. The domain is negative 4 to 4. You could also argue that these make the inside 0, and between them make the inside positive, and so you can kind of like talk it out if you'd rather, instead of doing this math work. I'm okay with that. Give me some idea of thought process. Don't just graph the damn thing and go, well, there it is. It's not the intent. Okay. And the range, we did an example of the range before for this kind of problem. How do I make the output the smallest? What's the smallest possible output for this?
Four.
No. Yeah, that's the input. What's the smallest possible? Okay, let me try it the other way. What's the biggest output for 16 minus x squared? 16? Because isn't it 16 minus positive number unless x is 0, yes? So what's the biggest way? Subtract the least, yes? You guys follow? You're analyzing a mathematical expression directly. Something you're not used to, I understand. But we've done something like this before. So the biggest the inside could be is 16. And what's the output when the inside's 16? What's the 4 through to 16? 2 times 3? 6. So the biggest output is 6. Now turn around. What's the smallest output? Well, what's the smallest you can make any fourth root? in the universe? What's the smallest output any fourth root can have? 0. So what, and then 0 times 3 is 0. So that's the smallest output this function can have. 0. So what's the range?
0.
From 0 to 6. Okay. Grand scheme of things, how desperately important is it for you to know how to do what we just did in the overall scheme of calculus? Not very. If you understand how to do what we just did, are you going to have a slightly better time with some of the stuff in calculus? Yes. So, okay. What about, is this one better? How do you do the domain for this one? What can't happen in something like this? Yes, the bottom can't be 0. So 7 plus 6x cannot equal 0. Solve for x. Students never seem to trust me about this. If I give you a function and I say find the domain, just say in English what's got to be true. Write what you just said in math. That's all. You're done. Bottom can't be 0. 7 plus 6x not equal to 0. Solve. Done. Okay. By the way, any problem we're talking about, if you want other examples, you just have to ask. If what I'm saying doesn't make sense, you just have to ask. That's what I love about teaching, man. Believe it or not, I love it when somebody doesn't understand the first way, because then I'm like, oh, here's a challenge. I got to figure out a whole different way to say it. That's cool to me. Worst thing in the world is look out there and see students going, well, this is my life. No, shit, no. Just ask. Just say, dude, I didn't understand what you just said, man. Try again. Yes?
So that one, I'm so sorry, really fast for that geofence when you put like cannot equal 0, is that when you use kind of like the U where you go from like the negative input
Oh, yeah,
to
yeah,
the
yeah.
output
Yeah,
and
yeah.
then the
Yeah.
union and
Yes.
to positive?
So this one, if you do 7 plus 6x can't be 0, you get x can't be negative 76, right? I would actually accept this as an answer. That's fine with me. If you wanted to put it in interval notation, you would just do this. So it goes from negative infinity to infinity. You just skip this one thing.
What's the difference for the parentheses and the brackets since you have an actual number?
What was this on a number line versus this? When I do this, what does this
Okay.
mean? What does this mean?
It's approaching, but it's not really.
It doesn't include it, correct? And if I cut that in half, that's a parenthesis, yes? What does this circle mean?
Has to stop.
You include it, and if I chop part of it off, it looks like a bracket, yes? So bracket means include, because it looks like part of an I. Parenthesis means don't include, because it looks like part of an open circle, yeah. You're welcome. And, real quick, just because. So you would graph this more like this, yes? And back in the day, I had students that weren't really sure about which way to shade, but I always talk about Dragon Ball. Doing a Kamehameha like that, and this comes out that way, yes? So they were always like turning their prints like the wrong way, but I'm just like, how do you shoot that shit out like that? So it's gotta be opening the way that you're shaded, open the way you're shaded, yeah, okay. Of course, we're not really worried about graphing that, so it's, yeah.
Can you explain how you found the range again for the first part of 2?
Yes. Range is all about outputs. So if I could just figure out what is the biggest output and what's the smallest output, that's my range, yes? So to make this the biggest output, I subtract the least I can, which would be 0. So the biggest output is the 4 through 16 is 2 times 3 is 6. Smallest output, what's the smallest I can make this? 0. In which case the output would be 0. So the range is 0 to 6. Yeah. Brackets, because I actually get those values. If I put a 4 in, I get 0. If I put a 0 in, I get 6. So those are brackets. Yeah.
So what would be the range for g of x?
Oh, this is the one. The way I did it on the answer key. you could get the horizontal asymptote here, because for very simple first degree rational expressions, the horizontal asymptote is a wall it can't go past. In general, do you guys remember you could actually go through the horizontal asymptote if you have more freaky rational expressions? When you find the inverse function, it actually will verify what you got. So right now, why is it so easy to get the domain? Because the bottom can't be 0 and the bottom is in terms of x. If I solve this for x, the bottom would be in terms of y. I can see what y can't be. And that's why it's related to finding the inverse then, right? Okay. But for a very simple rational expression, what is linear divided by linear, it can't go through its horizontal asymptote. So then you can just find the horizontal asymptote. That's the one value it's not an output. Because it's approaching, it never gets there. Yeah. All right. So we're obviously, next time is the test. If you feel like you're doing everything you can and you still feel unprepared, come talk to me. Right? I mean, I haven't had a ton of people come talk to me, so I mean, I know a lot of you haven't done that. So you can always come and say, listen, I'm doing this and doing this, I'm holding this system, I think I'm doing everything I can, and I still don't understand some stuff. All right, we can drill down to what it is. Yes? I can't do that from up here, looking at everybody at once. You can't do that. You've got the Math Science Center, yes? Where you have peer tutors who are students. You have the CISL, where you have the instructors, yes? You have a silly amount of help. Now, I know some of you guys are probably like I was when I was going to college, working 3 jobs. And you're like, I am here when I am not working. I am working when I am not in class. So what do you want me? So then just schedule some Zoom time with me. Shoot me an email and say, listen, dude, I can't make it to anything. Can't make it to anything. Here's when I'm free. Could you possibly? And I'm like, I'll work with you. Yes? Is that crazy? Why am I doing that shit? Because I want you to pass. That's what I want. I want you to pass. Of course I want you to pass. I could just give everybody A's, but no, that's the other side of me. I want you to pass because you understand the shit, yes? And it takes a lot to understand. It does. It takes a lot. Is there a lot in here? Yeah, because it's freaking calculus. So it's building off of everything from before. And if you guys took pre-calculus here at Guimaki, you know there's a lot in that class. There's a lot in the class. And now you're starting to see why. Because all of it kind of like comes in. So, I know it can feel very overwhelming. You've had the first few weeks. I'm hoping you found something that kind of works. You've got YouTube channels, you've got stuff, you got tutors, you got me. But again, if you really, really feel like, I think I'm doing everything, just come see me. We'll figure it out. That's the worst thing is if you feel like you're doing everything, you're still not doing what you want to do. It's almost better if I'm like, well, you're not doing this, start doing that. Okay. Okay. Anything else you want to focus on from this practice test? I think I can give out the answer key here in a minute. Question 4. Part C. So this guy. This one? Yeah? Okay. A really good way to answer that question, can you guys just tell me where this is discontinuous? Yeah, it's first thing you might want to do is draw the scale in there for yourself, right? So it's discontinuous at -3. So where's it continuous then so far? It's continuous from 4, 5, 6, 7. -7 to -3. You guys with me? If you see where it's discontinuous, you automatically know where the hell this is continuous. It's continuous everywhere between those. Where else is it discontinuous? Where's the next place is discontinuous? 0, it's got a major thing happening. And what kind of discontinuity is this here? Jump. What is this one? Infinite. That's crazy. Yes? That's infinite Vesuvius. Looks like a volcano. So we're safe because the lava's never going to come to us because it's infinitely high. That was really weird. I'm sorry. This one, there's a discontinuity here, correct? Does anyone know what this one would be officially? Infinite, because that trumps jump. So what do we have? We have -3, 0, 2, and 4.
Oh, one more on the end.
No, this is going.
It's discontinuous.
Yeah, that's continuous, yeah. So do you guys see what I mean? It must be continuous everywhere else. You're just gonna have a bunch of little intervals where you're gonna start at -7, stop at -2, 3. Start at -3, stop at 0. Start at 0, stop at 2. Guess, so you're gonna have like, where's the first place this is continuous? -7 up to -3. Start at -3 up to
0.
keep going. Okay. So if you can find out where it's discontinuous, you can list all the intervals where it's continuous. They just kind of start and stop where the discontinuities are. Bless you. Now I kind of went further. I didn't ask you on this question what type of discontinuities, but I just got threw that in there. So let me do this. Let me go ahead and give you guys the answer key. Since this is some of you guys' first practice test with me, don't do this. Don't go, yep. No. I would have done that. Right? Because then you're building up false confidence. So if you did not try out the practice test, do not look at this. Don't look at this. It's not going to do anything for you. So you can try the practice test, use this, or don't try the practice test. If you do all the homework, that's study. You're gonna be better ready for the test. Okay. So here you go. There's 2 pages to this, so just everything I give you is yours. It is in my writing, so I think I did some of my best writing. It's not saying a lot for you, Chad. I'm like, thanks.
Well,
Movie theater.
that's what it is, consistent, you can't say deep at all. We cannot say deep pictures.
Huh? Oh, yeah, I'm sorry.
That's what you had.
Sure. Good looking at it.
Closing. That's hater, wasn't it? It's consistent. Got over to, where do you
Sorry, stealing your papers.
Yes.
I think you just gave this to me.
Oh, wait. Oh, yeah, I already did.
Yes, you did.
For some reason, I thought I skipped y'all.
You usually do.
I normally do, yeah. Let me double check
Congratulations,
real.
you overcorrected twice.
Let me double check real quick. Anybody else not get their quiz back yet? Everybody got their quiz? All right. Yes. Huh? You need your quiz back? Oh yeah, that's right. I told you it wasn't really okay. All right. We still got time, obviously. So where else do we want to go? Oh, you guys have skipped. I know I skipped somebody.
No, we got the,
You got this.
but we didn't get our quizzes back.
Oh, your quizzes. What's your name? Wait, Sergio? Sergio what? Oh, there you go. Okay. Oh, I put you down because I thought it was an N. Omar, there you go. Okay. All right. Anything else you guys want to focus on? It could be from homework or from the practice test. It could just be general stuff. It could be stuff I went over already. That's fine. So you guys see what I mean when I like number 8? This is almost like the one we did earlier. Yes? Just a little bit worse.
I was gonna say, if any of them, could you go over 8B?
8B?
I'm sure it's simple, but
So let me see. When I say using the definition of derivative, that means the limit as h goes to 0. Yes? Okay. So what do we need for that? We need f of x plus h, and we need f of x. Obviously, I'm going to have to tell you f of x every time. So, of course, what do we have to figure out? Yeah, what's f of x plus h in this case? 1 over x plus h, yeah. So then if I do this, so this is the form of it. This is what we just figured out. So I put in here 1 over x plus h minus 1 over x all over h. F of x plus h minus f of x all over h. y2 minus y1 over x2 minus x1.
and we're just plugging it into what the limit formula would be, right?
The limit definition of derivative, yes.
Okay.
I just really want you, what does derivative mean again? Look, what is this limit definition built on? y2 minus y1 over x2 minus, it's just a stupid algebra thing, right? Why does it look so much worse? Because now, instead of y, I'm being more explicit. Y is an output when I plug something in. Okay, f of x plus h is y2, being more explicit. Okay. Now, a really good question is, what the shit do I do with that? Well, what's on the top of that thing? What are those? Fractions. How do I subtract fractions? Common. Yes? So, I like to make an analogy. If these are my kids, and you'll see why it's good I don't have kids. If these are my kids, the first one has x plus h. So the first one got like chocolate ice cream with sprinkles on top. And the other kid got strawberries. You with me? So this kid actually loves strawberries. He got the chocolate ice cream and sprinkles. You with me? He's like, oh man, got some strawberries, right? And the other kid's like, what the shit? I got strawberries. You got freaking ice. Can I get some ice cream and some sprinkles? So they each want the same thing the other one's got. You with me? Let me make sure you guys are really with me. Does this one have an x on the bottom? This one have an x on the bottom? No, it does not. It does not. If I had 1 over 6, would you say that has a 2 in it? That's 6? Yeah, it does. 2 times 3, yeah. Does it have a 5 in it? No. Even though it's 5 plus 1. So addition don't mean shit here. We want factors, correct? So, does the first guy have an x in it? No, because what does he have in the bottom? X plus h. So what is the first guy missing that the second guy has?
You need an X.
He he needs an x, so give him a freaking x. Yeah, so multiply by x. And what's he missing? X plus h. I mean, that's all freaking like the denominators is. That's it. That's all it is. It's just, if you have everything factored, you see what everybody's got, give everybody else what they're missing. Me, I would just look at them both and say, I eat everything. Nobody gets extra, so that's better. Now I've got the denominator is the same, so I can combine. Yes? Yeah. Give myself some more room. So this would be x minus x plus h. Is that cool? All over x times x plus h over h. Everybody's favorite is a multi-tier fraction, yes? So I've actually called fracception.
But you can get rid of it.
No.
No, you can't.
Nope. Can I cancel the x plus h's? Why not? Minus. Division doesn't cancel subtraction, yes? But what can I do on the top of that?
Cancel the x's and the h.
Do what now? Sorry?
If the x's subtract each other and then you can cancel.
Good, yes. X minus x is 0. Negative h is left up top. Now I could have rewritten this, but can you guys see what happens now? By the way, let me just rewrite this. Let me see if you guys are cool. If I cut a cake in half, and then I cut those in fourths, the cake is cut in. If I cut a cake in half, and then I cut in fourths, the cake is in how many pieces now? Eighths. 1/8. 1/2 divided by 4 is 1/8. Because if I start with 1 and then divide it by 2 and then I divide it by 4, I'm divided by 8. If I have a fraction divided by something, I could just put this there. Because this is not just being divided by this, it's also being divided by this. So at that level, I could just freaking put the h in the mix here. And then these h's. Now they cancel because now division cancels the multiplication. And what happens here? If I let h go to 0? Negative 1 over x squared. If I let h go to 0, I get x times x squared on the bottom. Yeah? So we started with the function 1 over x. If you wanted to, what's its derivative? Just always. If I see 1 over x, what's its derivative? Negative 1 over x squared. You never have to do this again for 1 over x, because we've already done it. Now you can just commit to memory if you wanted to. There's going to be a better thing to memorize. Yeah, but that's one little specific thing we know. If you ever see 1 over x, what's its derivative? Negative 1 over x squared. Done. So what's the slope of 1 over x at 0? Undefined, because the function originally is undefined. So of course it makes sense that the derivative is going to freak out. Yes. Okay. We did a problem earlier, and of course we did that before. If I know the derivative, I can figure out the slope, and then I can get the equation of the tangent line, yes? Is that okay? We can do that one if you want to. Yes? Okay. Here's a really, okay. I get the feeling, I need you to start looking at some of the stuff as useful instead of, oh shit, more stuff to memorize. You don't have to memorize what I'm about to show you, but has anybody ever seen this before? Okay, so maybe I can win some of you guys back. I can see in some of your faces like,
Oh, not this again.
I'm not sold on you. Oh, that's great. Thanks, man. Well, let's see if everybody agrees with you or not. Watch this, guys. What's x plus 1 squared? x squared plus
Do it.
2x plus,
101.
what are the coefficients of what we got?
1, 2,
1, 2,
1.
1.
Up.
It's yourself. So if I cubed it, what do you think the coefficients would be? 1, 3, 3, 1. In fact, if I cube it, x plus 1 cubed, well, that'll be x plus 1 squared, which we know is this, times x plus 1, and then I get x cubed, plus x squared plus 2x squared is plus 3x squared, plus x plus 2x is plus 3x, plus 1. 1, 3, 3, 1 are the coefficients, yes? Has anyone ever seen this before? Yes? So this is called Pascal's triangle. I think I heard a few people. Yeah. Pascal's triangle. And do you see how to make the next level of it? 1's on the outside. 1 plus 2 is 3, so what goes here? 4. What goes here? 6, 4, 1. So then if I did a fourth power, the coefficients would be 1, 4, 6, 4, 1. Yes? Now, real quick. X plus h cubed. See if you guys are cool with this. Without actually doing it, I want you to see how this goes together. What's the most x's I can get? If I do this times this, and then whatever I get, I multiply this. I can get x cubed, yes? So it starts off 1 all x's plus 3 1 less x, 1 more h, plus 3, 1 less x, 1 more h, plus 1, 1 less x, 1 more h. That's a hell of a lot quicker than freaking x plus h sometimes. Now you can start to see, earlier I said, what if it was a 7th power? Well, now it's still a little bad, but it's nowhere near as bad as writing x plus h 7 times. You could just go down to the 7th level of the triangle, and then do what I just did, yes? Do you have to do this? No, you could write it 3 times. You could write it 7 times. I don't care. And then multiply, multiply, multiply. Yes?
It's such a useful tool.
It is useful, which is why I don't understand why you were shitting all over it.
Oh, I wasn't. I was just like,
Okay.
oh, I recognize this.
Okay.
I have a bit of a storied history with it.
So that's why on this one, if I want to know what f of x plus h is, and it's x plus h cubed minus 2x plus h, now this piece is a little bit quicker to do, yes? In fact, we just did it.
That what you were doing up for?
Really fast.
Yeah, I did. Alright. So, what I always need from you guys is, let me know if you want to do another example, let me know if I'm going too fast. So, one thing I say a lot is, if I'm going too fast, slow me down. If I'm going too slow, deal with it. Right? So, if I wanted to do this, what coefficients am I using? 1, 4, 6, 4, 1. So I'm going to have all x's with a 1 coefficient. Plus a 4 coefficient, 1 less x, 1 more h. Plus a 6 coefficient, 1 less x, 1 more h. Plus a 4 coefficient, 1 less x, 1 more h. Plus a 1 coefficient, 1 less x, 1 more h. That is what you would get if you wrote x plus h 4 times, and then FOIL, FOIL, FOIL. It's a really useful tool.
It's much nicer than foiling, that's for sure.
Yeah. Do you ever have to actually use the Pascal's triangle if you really don't want to? No, you could write that 4 times and do it. It's not a big deal. It's not terrible.
Does that still apply if there were coefficients out there? No, right?
If there were what? Sorry.
If there were coefficients in the problem already.
Oh hell yeah! Watch this real quick. Since you asked. If I have 2m minus 7y to the 3rd power. Yes. You ready? So then I'm on this level now, right? 3rd power. So I have 1, all 2m's, no 7y's. plus 3, 1 less 2m, 1 more, I should say negative 7y is equal. Plus 3, 1 less 2m, 1 more negative 7y, plus 1, 1 less 2m, 1 more negative 7y. So and now I have to simplify, but the initial setup is always the same. It's called the binomial theorem, but it's built off of Pascal's triangle. And it's a thing that sometimes we skip, depending on who you take for teachers. They sort of either do or don't show you. But you can see how useful the damn thing is. I'm going to use it in chapter 3 to build a shortcut, thank to gods, because we're not going to want to do the limit definition forever. Yes? So we need to get some shortcuts so we don't have to do it for like x to the 87th power or something. So if I want to do this, we did x plus h cubed earlier. X plus h cubed, we got x cubed plus 3x squared h plus 3xh squared plus h cubed. Distribute to -2. And subtract f of x, yes? X cubed minus 2x. So when you have a polynomial especially, what tells you you're going in the right direction is if all the stuff without h is canceled, because then you can kill the h that's on the bottom. That's what tells you you're going in the right direction. Because then you'll be able to plug a 0 in for h. Okay. Do you notice how all the stuff without an h cancels? X cubes cancel, yes. -2x minus -2x cancels. Everything left I can divide by h. 3x squared h divided by h. 3xh squared divided by h. H cubed divided by h. -2h divided by h. Now can I plug a 0 in for h? Yes, because I killed the problem. When I plug a 0 in for h, these two go to 0. So I get 3x squared minus 2. So f prime of x is 3x squared minus 2. And again, what is this function's purpose? Not pass the butter. The function's purpose is to tell me the slope at any input I give it, right? So if I want to slope the function at 1, I plug a 1 in, it tells me the slope. Okay.
Number 12, because I'm getting 0.
Well, real quick, I think somebody wanted me to do number 9 here, right? Or no? So real quick, I know the function is this. Oops, let me put my glasses back on. Is that a 2? 2x, yeah. And that's a 3. And I know my derivative we just got is this. Yeah, with x. So they already gave me the full point, because normally I have to plug the x value in to figure out what the output is. -2 cubed is -8, plus 4 is -4. So that's where I got that point from. What else do I need for the equation of the line, the change of line? We got a point. What else do I need? Slope. And what's going to give me the slope? Plugging into what? Say again?
You plug it into the derivative.
Yes. Because what's the derivative, Sean? If I feed it an input, it tells me the slope there. Why does it do that? Because we built it from y2 minus y1 over x2 minus x1. So what slope do we get? -2 squared is? All right, let me catch up. -2 squared is 4 times 3 is 12 minus 2 is 10. So now I can use this, and I can plug in, what's my output? -4. What's my slope? 10. What's my input? -2. And then you can simplify and you're done. That'll be the equation of the tangent line. And then if you were to graph the function and you graph the tangent line, it'll hit that function right at one point, fly off just like this. Yes?
Number 7, I'm confused on for that test.
Oh yeah, well 7 is extra credit, right? So that's from the 2-4. So I'm gonna hold off on that until the end. Yeah. Unless nobody else, if nobody else has any questions, then I'll go ahead and do that. You guys, anything else you want to focus on?
Number 12.
Oh yeah, 12, sorry.
Do you have
So when you go to make table of values for this, you want to kind of estimate what this is. Yeah, 1.57 roughly. So then your inputs could look like, I want to approach 1.57, blah, 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 right? So I can go 1, 1.4, 1.5, 1.57, right? Yes? And then I can go from the other side. I can say 2, 1.7, 1.6, 1.58. So, do you understand? Pi over 2 is roughly 1.57. When we make a table of values, what are we trying to do? We're trying to get really close to the weird point. And you all agree weird things happen at pi over 2? What's close down to pi over 2? 0. And what's twice pi over 2 minus pi? 0. So you get an indeterminate form. So something weird is happening at pi over 2. So we're going to be the smart people that saw the meteorite come down. We're not going to touch the blob that came out. We're going to get really close. You go, what is that thing? We're not going to grab it. We're going to get close. Where'd this number come from?
pi over 2?
Yeah, it's what pi over 2 is. So I'm going to slowly get towards 1.57, and I'm going to slowly get towards from the other side. So then I can see, does it look like it's approaching something from both sides? So just plug that stuff in. Make sure your calculator is set to what? Radians, yes. When in doubt, radians.
So we can plot it in our,
And then you could do the table if you want to, yeah.
but it's giving me 0 and you have 0.5, negative 0.5.
Whoa, can't see. Let's see. What's on the plan? Oh, I see. Do you see the 2 is not outside?
So,
Something really weird here.
Yeah.
Too many eyes going on. Oh, is that what you did?
so I was plugging
The
in
bottom
the-
should be. Oh, you plugged in the number. You see how you have no x? Right?
Mhm.
So the bottom should just be 2x minus 4, right? Oh, wait, sorry. I'm looking.
Pi.
Yeah, 2x minus pi. I left the 2 out too.
Yeah, I was plugging the pi over 2 into the hex.
If you plug it in now, then the table will never have a different value.
Okay.
Because it'll always only, yeah, if you don't have an x in your function, it's never going to change.
Oh, okay.
Yeah. Let me ask you guys something. I think I put up in Canvas the list of resources, like all the various Professor Leonard and all that kind of stuff. You guys, did I put that up in our Canvas shell? The resources for passing calculus?
I think so.
Okay. Alright, you guys have to help me. If you're having trouble, if you're like, what more can I do? Ask me. So, I'm pretty sure I did. I put up in Canvas, I'm pretty sure I flashed it up here. a list of resources, books, YouTube links, right? Professor Leonard, organic chemistry tutor. You guys have heard of some of these people. There's books you can get to study. When I teach this, I try to show you how if you break it down into parts, it's not as difficult as it seems. That sometimes comes off as if, well, this is supposed to be easy. This is not supposed to be easy. I'm trying to show you how you could make it easier. Yes? So I don't want anyone to come out here feeling like, well, if I can't just do this automatically, it must mean I'm not doing this well. No. All that said, you have to let me know when you hit a snag, when something's not making sense. If you don't let me know, there's nothing I can do about it. So, is there anything else on here you want to focus on? Yes?
Can we try 10A?
Yeah. So 10A, what are we approaching? Yeah, so this is where, and what kind of a function do I have? I got a rational function, yes? This one specifically is not a rational function, but we all talked about how I could look at it the same way. So when I'm going to infinity, what rules the day? What do I look at when I have a rational function? The degrees. So what's the degree of the top? What's the degree of the top? 3, third degree, yes? What's the degree of the bottom? So since I'm going to infinity, what's the limit?
1/5.
Negative 1/5. The ratio of the leading coefficients. I showed you why that's true, but now you can use the shortcut, yes? What about over here? What's the degree of the bottom? 2. What's the degree of the top?
2.
Good! It's not 4th degree, right? Because I'm square rooting everything. So are the degrees the same? So the answer would be, since I'm going to infinity, the ratio of the leading coefficients. What's the leading coefficient on the top?
3.
Good! Square root of 9 is 3. What's the leading coefficient on the bottom? So it'll be 3 over negative 6, negative 1/2. So sure, of course, if it's going to infinity, you're going to look at it different. Do you have to memorize that? Well, of course you do. It's not like, oh shit, I got to do this too. No, of course you got to know. When you're going to infinity, you got to look at it a certain way. If I'm going to 2, you're not going to look at it the same way as if you're going to infinity. That just makes sense. That's not like, oh, extra shit to memorize. That's like, oh, that makes sense. Things are going to be different if I'm going to infinity versus 2, yes? So if you are going to infinity and you have a ratio of things, you can think about it in terms of degree, yes? Now, if this would have been 3rd degree, does anyone know what the answer would have been? What's the top again? 2nd degree. Bottom, if that was a 3rd degree, which one's growing faster? So I'm dividing by a bottom that's growing bigger than my top can handle. So what am I going to? No, the bottom is what I'm dividing by, yes? So if I'm divided by something that's growing faster than what I'm dividing it by, into, I'm going to freaking 0, yes? Big divided by really freaking big, it's going to 0. 1 divided by 10, 2 divided by 100, 3 divided by 1,000. They're both growing, but the bottom's growing faster, yes? Okay. So the bottom degree is higher, I'm going to infinity, that goes to 0. Equal degrees, ratio of the leading coefficients. If the top degree is higher, that's some kind of infinity. And then we worry about is it negative and positive infinity. Okay.
How does it work with the C one?
Oh yeah. See, it's funny because if you do one thing, it's easy as hell. What's the negative power mean? What's the negative power mean?
Did you put it on the?
Yeah, it's a 4-letter word starts with F that you can say in mixed company. Flip. So that's all a negative freaking power means. So what's to a negative power?
E to the 3.
Good. So those go on the bottom. And then what's the bottom doing now? As I let x go to infinity, what's e to the 3x doing? Going to infinity even faster. So it's 5 divided by bigger, bigger, bigger. So what's the output's going to go towards? 0. Done. So I was just, can you rewrite it? So now you got a ratio where the top is finite. If the top is finite and the bottom's going to infinity, that's 0. I don't even have to worry about if it's negative or positive because 0 is 0. What about number 6? Students sometimes forget one thing. What's the most immediate thing you want to check to see if this is continuous? Where's one place it could blatantly be discontinuous? At pi over 3. That's the thing I was trying to talk about, the handoff. If I'm looking for the baton and you're over there, I'm like, we're screwed. Right? So they got to match up. So if you plug a pi over 3 in to each one, you do get the same output. Just spoiler alert. So where else could it be discontinuous? You have to look at each function, right? Remember we had a problem where it was 1 over x? Could that be discontinuous? 1 over x. Could that be discontinuous? Does 1 over x have a problem somewhere? 0. So if it was defined where x could be 0, so we had a problem like that before. Does cosine have an issue? Is there anywhere? What's it always look like? So does it have an issue? Does it do weird shit? No, it's fine everywhere. So you would say trig functions are continuous everywhere. So that's good. What kind of function is this? This is kind of silly. It looks really complicated, but what is it? What kind of function is that? Could you pull the negative 6 over pi out in front of x? Isn't that just freaking linear? What power is the x to? First power. That's linear, automatically. Is the coefficient weird? Negative 6 over pi? Is that a little weird? I appreciate that. I like that. Well, would negative 6 divided by pi be a nice number? Okay, that's what I mean. Okay. I'm okay with that. I agree with you. But still, most people will say it's gross. But it's just freaking x. It's linear. Is that discontinuous anywhere, a linear function? No. So, neither function has an issue. And the pi over 3 does agree. They're both in the same place. The handoff happens correctly. So, done. It's continuous everywhere. So what do you have to check when you have a piecewise function? Does the handoff work correctly? Meaning, when I plug that in and I plug that in, are they the same so that they fill in each other's holes? That's really a bad way to say that. We're going to get past the phrasing.
Do they click together?
Yes. They become one. It's even better. Check that. But also, each function has to be cool with all of its possible inputs. So if I put like 1 over x here, would that have an issue? Right here. If I replace that with 1 over x, would that have an issue? Because it's not allowed to be 0, so it wouldn't have an issue. It would be continuous everywhere it's allowed to exist. So that's what you check. If I give you piecewise, say is this continuous? You got to check the handoff, and you got to check each function. There's a really cool theorem. Let's see if I can find it really quickly. That says trig functions, exponential functions, logarithmic functions. Here. All of these are continuous on their domains. So, for example, if I have 1 over x minus 2, that is a rational function. What's 1 over x minus 2? What's not in its domain? 1 over x minus 2. What is not in its domain? 2. It is continuous everywhere else except 2. And if you draw the damn thing, you know it's continuous. It does like this. So it's beautiful everywhere until it tries to get to 2, and that's where it freaks out. So that's what this means. It says, yeah, logs have issues. Rational functions have issues. Roots have issues. But where they don't have an issue, they are continuous. They're continuous everywhere on their domain. And polynomials are the ultimate, like, best thing. They're the most valuable. They're the real MVP. Because they're just cool everywhere. They're just cool everywhere. So yeah, if I give you a piecewise and it's got a trig function, and you can just say, well, trig functions are continuous everywhere on the domain. So there you go. You just gotta make sure that the domain is acceptable. All right. Anything else, guys? So somebody asked me to do the extra credit one, so I'm gonna do that. If anybody wants to see that, it's on this answer key too, I believe, but we can do that together. If you don't want to see it, you can head out. If you have other questions besides that, you have priority, because this is extra credit. So I'm not even. Nobody has questions, I'm gonna do it. Okay, I'm gonna assume everybody else wants to see it. If you don't want to see it, you can head out. So these guys, the whole idea is if I'm given an epsilon. So somebody tells me, this is like I did earlier. Somebody tells me, okay, if the limit really is 3 or whatever, I want you to get this close to it forever. We talked about that earlier with the cosine. As long as it's damped, it'll get that close. So the challenge is, if somebody gives this to me, I need to find a delta so that if we are close enough to the input, then we'll be close enough to the output. So somebody says, I want you to be this close to the limit forever. And we're like, so we have to find how close we need to get to the input so our outputs are always that close, at least. So delta is a distance on the x-axis. A math person would normally look at delta as being a very small positive number. Same thing with epsilon, but epsilon is on the y-axis. So limits, would you all agree that limits rely on the word close a lot? As you get close to 5, you have to get... So what's the limit as x goes to 5? All right, here, let me ask you this. This is something independent of this problem that you have to be able to do. Can you tell me what this says, what this means in words? And I don't mean read it off to me. As our inputs get close to 5, our outputs get close to 7. As our inputs get close to 5, right? A is whatever that is. So that means close on the x-axis. As our inputs get close to the input, at 5 in this case, our outputs get close to the supposed limit. This formalizes the idea of close. So let me show you real quick, just to show you so there's A. It could be like 5, yes. Whatever I'm taking the limit as x goes, yes. What does this really mean? This means I can go up by delta and down by delta. And if I consider delta to be a very small number, isn't this really close to A? You guys go. And if A supposedly has a limit of L, then if somebody gives me an epsilon, this is L plus epsilon, this is L minus epsilon. So if I'm within epsilon from L, I should always be able to find a delta so that my outputs are always that close. If I can't do that, then I've got my limit in the wrong place. And we know this. The way you read this tells you this. As I get close to 5, okay, as my inputs get close to 5, my outputs better get close to 7, from what I wrote there, yes? This formalizes that. big time. So, just remind you guys, this is extra credit, but I appreciate that a lot of you guys are still here. So for us, what we have to do, in this problem, f of x is 8 minus 3x. What's L? 14. What's A? Negative 2, good. So, what we have to, the proof says, given epsilon greater than 0, let delta equal, we don't know yet. So that when x minus negative 2 is less than delta, that leads to us having f of x minus the limit is less than epsilon. So when I am this close to negative 2, that forces me to be this close to negative to 14, sorry. That's the idea. The reason this is blank is because we have to do some side work. So I know that I want to be, so somebody gives us epsilon, correct? Somebody comes along and says, I want you to be within 0.01 or whatever. They give us epsilon. So I know that 8 minus 3x minus 14, this distance between my function and my output has to be less than what they said. Yes? That's the idea. I have to be that close to 14. Can you simplify that? What can you do here? Simplify that. What do you get? What's 8 minus 14?
6.
What's 8 minus 14? There's 6. So all I did was simplify, yes? Okay. Can you factor something out of here? Negative 3. What's the absolute value of negative 3? 3. What's the absolute value of x minus 2? I don't know. Oh, sorry. It should be plus 2 because I factored a negative out. You guys with me? Then I could divide by 3. Now, look. This is really trippy. What is this? What did we just figure out? Oops, I lost my answer. What do we want delta to be? Can you guys see? No, what do I want delta to be? Look, x plus 2 less than delta. I want delta to be epsilon divided by 3. So, our function, somebody says, I want you to be this close. I want you to be epsilon away from your output. And we go, oh, if we just make our inputs 1/3 of that away from negative 2, we will always be that close to 14. That's the idea. So it feels like cheating because we kind of, here's the funny thing, going forward, if I let delta be, what time is it? Oh shit. If I let delta be epsilon over 3, then I could just put that in here. So let delta be epsilon over 3. So x plus 2 less than epsilon over 3. I can multiply both sides by 3. I can, 3 is equal to the absolute value of negative 3, yes? Then I can bring that back in. I basically do all this work backwards. And that's the part that feels like you're cheating. And just to remind you guys, I did give a handout that's got a fully worked out example of this. And then, so what's weird is this step, the minute you're done with the side work, you're basically done. You know what delta's supposed to be. You just have to write, given epsilon, let delta be this, so that when we are that close to negative 2, then you just copy this shit backwards. We are therefore that close to 14. When my inputs are this close to negative 2, our outputs will be this close to negative 14. That's what tells me that really is the limit. And I have to run. I have to run to the sisal.
Thanks, Jeff.
Anytime.
That's not Monday, right?
Monday.
I gotta redo something.
Okay. Don't forget, I'm in my office normally before 11:45. I'm officially 11:45. I'm normally in there at 11 on Monday. So if you want to, come by on Monday.
Is it the whole